remember the relationship between parallelogram, triangle, and trapezium. You remember yesterday, this was the applet I used. So let me do something. Just watch as I explain some things here. So this is a rectangle. This is a rectangle. You can see it. And yesterday, if you remember, I did something. I said a rectangle, the height, which is the length, the height now, that this place that represents the breadth, is always 90 degrees to the base. So that's why we say triangle have 90 degrees as all the angles. Then if this angle that is 90, let me put the angle so that you understand what I'm saying. So this angle at this place, let me use this to explain. You can see it's showing 90. This is 90 degrees. You can say this is 90. So if you move the top now, if I slant this top, you see the way I'm slanting it, it's no more 90 degrees. See, it's now 78.69. So because this is no more 90 degrees, it's no more a rectangle. The name now becomes a parallelogram. So this is how parallelogram is formed. Just bend the 90-degree angle of a rectangle, just slant it a little to one angle, you have a parallelogram. So this was what I explained yesterday. You can take it to this side, you see this is a parallelogram, or to the other side. Then remember the condition, I gave the condition yesterday. The height still remains 90 degrees to the base, that is this one. The height still remains 90 degrees, which is 1, 2, 3, 4, 5. In this case, the height is 5. Now, if this height, let me put the length. If this length now, this length that is 5, when the time is changed and this 90 is changed, we now call it a parallelogram. And that was why, if you remember yesterday, I did something like this. Now I created a line like this. Sorry, let me create my straight line first. I want you to see this. You can try it when you get home so that you understand how this thing is being formed. So if I have my perpendicular, let me create a point outside, something like this. If I have my perpendicular of this line to this, I can actually create a height from here to somewhere here, such that I can hide these other ones, hide this, and this one can move along. You can see it. So as long as this height remains constant, this height is 5. Let me put the length. This height is 5. As long as this height is 5, the area of this, what is it called now? The area of this triangle remains the same, which is 45. So the area remains 45. Just add 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 times 5, that is 45. So if I twist the leg, let me move this top. So if I move this top the way I explained it, you can see that this place is no more 5, it's now increased, it's now 5.1 something. Let me make it very long, let's go far. You see, it's now about 7, but this height still maintain 5. You see, but the area did not change. That is because in parallelogram, we only consider the area, we only consider the height times the base, and we say this height must be 90 degrees to this base. So that is one thing I want us to get. Rectangle and parallelogram, they are similar because of these characteristics. See, the height still remains the same anywhere I put it. As long as this shape, as long as this top keep moving like this, the area will not change as long as we maintain that height. You see, the area still remains 45 centimeter square. All right, now this is what I want us to get. If I decide to divide this shape into two now, instead of using this parallelogram, I now cut it into two. Let's cut it into two, something like this. I now cut it like this and divide it like this. You see, I have two triangles now, no more a parallelogram. And remember, we call this place the base. Anywhere parallelogram sit on, we usually call it a base. And this one, we call this the height. So let me label it from the system. So let me put the value of this. Let me put the name, sorry, name and value, that is h. You can see that is the height. So the h is 5, so it will continue to maintain 5 as long as I move along this line. Okay, now I've divided this parallelogram into two. You see a new shape is formed, which is triangle. So if I sketch a triangle on that division line, something like this, something like this, something like this, something like this, you can see that I can erase this part. Let me erase this part. See, and I have a triangle. The angle, let me erase it as well. See, and I have a triangle now. So I don't need this area again because I've removed it. See, from parallelogram, a triangle is produced and the same formula remains the same. This triangle will have area that is 45 divided by 2. If I put it there, you see that 45 divided by 2 will be the area of this triangle. You can see. By the time you divide 45 by 2, you will see that it's giving you 22 and a half, which is 22.5. So this triangle came from half of a parallelogram. So that's one thing I want us to get. And that is why this formula, you can see why the formula says area of a triangle is half base times height, because triangle actually came from half of a parallelogram. Triangle came from half of a parallelogram. So that is why we call the area of a triangle half base times height. And we say this height must be 90 degrees. See, that is why in triangle, if you observe, we always draw the line from the top here to the base of the triangle, and it must be 90 degrees. If it's not 90 degrees, the formula will not work. Now watch, if I move this top now, let me shift this one out of the point. If I move this point D out, you see the area change, but if I maintain the same height, see the area will remain 22.5. This is also a triangle. These two slant heights here, you see they have changed, but the area remains the same because I maintain that same height of 5. If I move it to, let me move it to somewhere here. Let me shift the height. Let me draw the height back. So I've maintained the normal height. You see, the area still remains the same. So no matter how your triangle is being drawn, parallelogram is always half of a triangle. So anywhere your triangle is positioned, just know that the height you are using is the height that is 90 degrees to the base. So the triangle is positioned like this. This is the height, 5 times this base, which is 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer you get divided by 2. That is half base times height. Take note of this. Now, let's move this out. So this triangle, as I said, you can place it anywhere. A triangle is a triangle. The formula remains the same. It will not change. You can make it a right angle triangle, something like this. This is 90 degrees. You can make it a right angle triangle in this side. It's the same thing. So take note of that. All right, let me delete this. Let me explain trapezium for us. So let's delete all this. Okay, let me leave this height. I don't want to delete the. Let me leave this height. Okay. Let me drag it up. You can actually do this at home. As I'm playing around with it, you can do it at home to understand it better in your own way. Now, this triangle we have, remember, I want to get a trapezium. If I need a trapezium, what I need to do is easy. Just cut this triangle, cut it in a way that the line that cut it is parallel to the base. So if I take a line, let me take a segment, something from here, I draw it to this place. You see this line is parallel to this base. You can see that a trapezium is at the base now. Let me remove this area. Let me remove this area. So if I make a sketch of a polygon from this point to this point to this point to this point to this point, you can see that if I take away this triangle out, watch what will be formed. See, a trapezium is being formed. You can see that a trapezium is formed when you remove the head of a triangle. By the time you cut off the head of a triangle in such a way that this top here, you do it in a way that this top is parallel to the base, you will see that a trapezium is formed. That is how trapezium is being formed. So take note of that. You can see that this is a trapezium gotten from the base of a triangle. Cutting from This is a trapezium you got from cutting off the head of a triangle. So take note of that one. Take note of that. So that is a trapezium. So trapezium is being generated when you remove the head of a triangle and it will give you a neat shape called trapezium. But take note, the condition for trapezium is this side must be parallel to the base. The two bases must be parallel. Let me show us something again on trapezium before we end our lesson for today. So this is an app also that you can easily sketch your trapezium. So let's see something here. Let me go to polygon. Okay, this trapezium. Just watch what I will do here. All right, as I click on the base and drag, just watch. You see, this is my trapezium can either go in any way. You can see if you observe one thing, you will see that the way it's being done, the parallel side are this place. So this is the parallel side, this top and this base. These are the parallel side. So these two sides does not really need to be parallel in trapezium because it actually came from a triangle. So when you remove the top of a triangle, a trapezium will be formed. So this trapezium actually came from a triangle, something like this, that the top has been removed and triangle is generated. Just something like this. Let me sketch a triangle on top so that you know what I'm talking about. See, something like this. So you can see it. See, something like this. So there's actually a triangle. So by the time you remove that triangle, what will be left underneath now will be a trapezium. So take note of that. All trapezium came from a triangle. All trapezium came from a triangle. So that's one thing I want us to take note of. So very, very important. All trapezium came from a triangle. So don't forget that. So this is just the demonstration I want us to see. So that is that. Alright, let's end the lesson today. So this is a trapezium. If I impute some properties, let's see something. If you see parallel, if I click on parallel, you will see the two parallel side. So these two sides are not parallel, it's only the top and the down. So these are the base. So the small base we usually call it A, while the big base we call it B. So if I move one of these points, you see this is also a trapezium. You see this is trapezium. As long as the opposite side are not all parallel and equal, it's a trapezium. So this is a trapezium as well. I can move this place like this. This is a trapezium. See, so just remember one property of trapezium. Opposite side, you have one pair of parallel side. So you have one single pair of parallel side. So this side must be parallel to this side. So that is one major property of trapezium. So this is also a trapezium and it actually came from a triangle. By the time you remove the top of a triangle, what will be formed will be a trapezium. That is all I have to demonstrate this.